Okay, we're back. All right. So that was properties of logarithm. Now let's talk about solving log equations. So I have three examples I would like to go over. On page 480, let's look at, so it's page 480. Let's look at number 7. So number 7, we have log of x minus 15 minus 2 equals negative log of x. So we're going to use the properties of logarithm to solve these equations for x. All right, so I would recommend that you add, move all the x's to one side and then move the constant to the other. So I'm going to add log of x to both sides, and I'm going to add 2 to both sides. Cancels, cancels. So what do I have? I have log of x minus 15 plus log of x equals to 2. Now I'm going to simplify the left side. Do they have the same base? Yes. How do we know? Because if the bases are not shown, then it's common log base 10. And it's a plus sign, so I can condense it into this. Right? Now, what do we do next? Well, I have a single logarithm, right? What's the base? 10. Can I write it in exponential form? Yes, to get rid of the logarithm. So 10 to the power of 2 equals to this. So I have x times x minus 15 equals to 10 to the second power. And what do we have? We have x squared minus 15x equals to 100. Don't write 20, that's 10 squared. And then x squared minus 15x minus 100 equals to 0. And what do we have? Well, we can factor this. So x and x plus minus. What are the factors of 100? 100 times 1, 50 times 2, 25 times 4, 20 times 5. Which one can give me 15? 20 times 5. Which one should be negative? I want a negative 15, so the larger factor has to be negative. Then what do? The zero product property. So x plus 5 equals to 0, x minus 20 equals to 0, so x equals to negative 5, x equals to 20. So here's my answer, because logarithmic equations cannot have negative answers. So this is an extraneous solution. Extraneous solution. A solution that does not work for an equation, we call it extraneous. So negative 5 is extraneous. So we solve the equation. Okay. Now let's try number 14. I'm going to do it right here. This is on page 480. Number 14, we have log base 3 of x plus 6 minus log base 3 of x equals log base 3 of 5. So do we have the same base on the left side? Take a look at it. We do have the same base. It's 3, so can I condense it to one logarithm? Yes, and how do I condense it? By division. This is an example of the reverse of the quotient rule for logarithms. So I can write as a single logarithm x plus 6 over x equals log base 3 of 5. Okay, now let me give you one more rule here before we go any further. If you have two quantities that look like this. If you have a single logarithm on the left, a single logarithm on the right with the same base, you can just cancel these guys and set these two quantities equal to each other. Okay, so it kind of relates to the other property I showed you for exponentials. But anyways, do we have a single logarithm on the left? Yes. Do we have a single logarithm on the right? Yes. Do they have the same base? Yes. Forget about them. So I got x plus 6 over x equals 5. Now how do I solve for x? Well, can I multiply both sides by x? Yes, I can. X's go away. X plus 6 equals 5x. And can I subtract x from both sides? Yes. So I get 6 equals to 4x. And divide by 4. So we have x equals to 3 over 2. Reduce the function. I'm sorry, I'm talking about functions all the time. Reduce the fraction by 2. So that's that. All right, it's not negative, so the solution is acceptable. Okay, and the last problem on the same page, on page 480, I would like to do number 20, because number 20 involves natural logarithm. So that's natural log of 5 plus natural log of x minus 2 equals 1. Again, I have same base. I want to simplify this, so same base, because the bases are e. I have a plus sign, so that will be a reverse of the power. I'm sorry, not the power, the product property. So I will get this equals 1. So I have a single logarithm. I want to get rid of it. So anytime you have a single logarithm and you want to get rid of it, put it in exponential form. So is this base e? So can I write it like this? You don't have to, but I just for visual, can I write it like that? So what's the base? E to the power of whatever is on the other side equals to this. So I get e to the power of 1 equals to 5 times x minus 2, right? Now it's in exponential form. I don't have to worry about the logarithm. So anytime you have a single logarithm, change it to exponential in order to solve it. Okay, so you can get rid of the logarithm. So what is e to the power of 1? That's about 2.71 approximately equals 5x minus 10. I'm distributing the 5. Can I solve for x? Yes. So I'm going to add 10 to both sides. And I get, what is that? 12.71 equals to 5x. And I divide by 5. And this is when I use my calculator. So let's be a little bit more precise. So if I use the e, so that was e to the power of 1. Well, it's 2.718. Okay, so I just put an 8 plus 10. That gives me 12.718 divided by 5. So what do we get for the answer? The answer is 2.544. So we solve the equation for x. So these are examples of solving logarithmic equations. All right. The next video has a lot of application problems using logarithm and natural logarithm and exponential functions, and they're all related to finance, like simple interest formulas, compound interest formulas, interest that is compounded continuously, annuities, and so forth. So next time we'll talk about the application of these rules and concepts of exponential and logarithmic functions in the finance. Okay? Thank you very much for watching, and talk to you guys next time. Bye.